Hey YouTube, let's discuss LeetCode problem number 173, binary search tree iterator. But before we discuss, please share, like, subscribe, and hit the bell button for notifications. Also, I have added a lot of quizzes to the community page. Please check it out. Now back to the problem. Just like all iterators, this binary search tree iterator, you are supposed to do in order traversal, meaning left, root, and then right. That's the order in which it's always relative to the root, the in order, the pre-order, and the post-order. If you process the root first, then it is pre-order. If you process the root in the middle, then it is in order. That's what we are going to do. And if you process root at the end, it is the post-order. So now you are supposed to, I think it's better if I show here. You are given a BST iterator class, and you are supposed to fill in the constructor, then the next, and the hasNext. That's all your job is. So when if you call hasNext, say while hasNext you do next on the object and then print it. So that's one simple use case of this iterator. So the constructor initializes the object, and then boolean hasNext returns true if there is a number to be traversed, and then next actually returns the number at the current node. So let's take a look at the code. I call this as a stack all left nodes pattern. As we will see from the at the constructor, we just push all left nodes of the root, and then the rest of the stuff will dynamically push them here. And let us take a look at the push all left. All it does is, given a node, and if the node is not the null, it pushes that node and then pushes the node to the left. Basically, it keeps on doing that, pushes all the left nodes. And so in this case, let me explain. So it will push 7, and then it will push 3. That's it. It will just push only 2 nodes. And then hasNext is when the nodes is not empty. That's when you return true. If there are nodes in the stack, and then this is a stack which we maintain in order to do the in order traversal. So if it is not a stack, if there are elements in the stack, then you say true. And the next one is you pop the top element of the stack, and that's what we return. But before we return, you push all the lefts of the right node. So that's what is the lazy evaluation or lazy of the binary search tree iterator. So let us look at with an example. Like in this case, as I said before, in the constructor you start off with the root and then push all the left nodes. In this case, you just push 7 and 3 are on the stack. So in this case, like for example, if you start calling hasNext and then next returns 3 first, because it's at the top of the stack, and then current stack state is 7. Next is called returning 7, but before we return 7, you push the 7's right node. So which basically this 9, 20 and 15 acts a new subtree. So now you push 15 and then 9 onto the stack and then return 7. So you got 15 and 9. So once again you call hasNext, and then you say return true, and then return 9, and then when you call 15, that's when there is a right node available here. There is nothing right available out of 9. So if there was a right node here, then that would have been processed before returning 9. So when you process write node is there, and then you process 20 and return 15, and then you hasNext once again is called and 20 is there, so in the stack, so you return true, and the next is called 20 and then there's nothing right of 20, so hasNext will return false. And I hope this is clear. Comment below if you have any questions. Otherwise, I will see you in the next video. Bye.